All right, guys, welcome back. So this is going to be video 3 in the series, Tuning Foxbody Mustangs for Boost. What we're going to focus on today is doing the first part of the tricky scaling required to get good spark control in your tune. So if you remember from the last video, we had simplified things down to where essentially everything's going to run off of one timing table, your C-level timing table. And that's going to make things easier for you to tune. You only have one table to work with. Makes things a little bit easier. But there's some big limitations of that table. And so the first limitation that we're going to cover today is RPM. And you'll notice that in this table, you have a working range of 500 RPMs up to 4,000. And then we have no additional control above that. So, obviously that's the biggest issue we need to work out first is we want to get into at least 5,000 and 6,000 RPMs. And it kind of depends on your combo beyond that. I know some guys are going to wind it up higher, but most of the stock block type combos don't like a lot of RPMs anyways, especially full stock bottom end. And I know that's a lot of you out there. So what we're going to do in this video is we're going to scale up to 6,000 RPMs and we're going to talk about some of the other things that you have to do to accommodate that. So the first thing we have to do is make a decision as to which of these existing columns we're willing to get rid of or how we want to ultimately change this, because we still have the same total number of columns available, but we can choose what each of these columns is going to be. Now, the first thing I'm going to call out is this. This is a useless column because, again, your idle timing is not controlled here. This is only when you're driving and the vehicle's moving. So there's really no situation at all where that car is operating and you're at 500 RPM. So really don't even hesitate. This row or this column, this one can go. Now, where you're setting your idle, is going to really depend heavily on your cam and a few other factors, but kind of depending, it could be anywhere from maybe 650 RPMs to maybe 850 or so. If you're running some really radical cams, you might have to go a little higher than that to make things happy, but that's, again, not going to be most of you. Even stuff that's in the, mid 500s or high 500s lift and getting into, 230 and, maybe a little higher duration at 50. Even those kinds of cams, if they're set up well for your combo, shouldn't be too lumpy. So what we're going to do is in this video, we're going to kill this column. We're going to kill this column. And what that's going to do is allow us to shift everything over. So the first column will then become 900. And ultimately, we'll have 2 additional columns at the top. So now we can have a 5,000 and a 6,000. And the reason I like to do this, a lot of guys argue that you don't need so much focus. I mean, there's every couple hundred RPMs through here, you've got another column. So a lot of guys will argue you don't really need to have this much detail here. You can free up some of the mid-range, but this is where I kind of have a difference of opinion. I like to focus on drivability, and street cars are going to spend a lot more time in here than they are, up here and beyond. So I really don't like to sacrifice a lot of this. So really what I like to do is, especially when you're new for tuning, is keeping things as close to stock as we can, but giving us a few additional options that we wouldn't have otherwise. So we're going to kill these 2, shift everything over, and we're going to pick up a 5 and 6. Now, how we do that is we go into the system folder, down into scaling, and there's going to be a table right here called Spark Fuel and EGR Table RPM Columns. So we're going to go into that. Now, the way that you set this up is kind of weird. Again, we've looked at a little bit of scaling, but you have to kind of think about things in terms of what the column number is and what that corresponding RPM is going to be. And if you have gaps, like we jump all the way from 0 to 5 here, then it's going to fill in all the columns in between with, however that averages out through that range. So the first thing we decided is that our first column, which is essentially column 0, we want at 900. So we know that that's going to be a key value. And then if we think about what the factory did from there, they went up to 1100, then 13, then 15. And then that's where you no longer have a linear, change of 200 RPMs per column. So from 900 up through 1500, 9, 11, 13, 15. So we're going to have to put this guy up at 3. So 900 will be column 0, 1100 is 1, 1300 is 2, and 1500 is 3. So that gets us to here. Now, when we go from 1500, we go from 15 up to 2,000, then to 25, then to 3,000. So again, 15 to 3,000 is all linear curve too. So 15 is at 3, 2,000 is at 4, 2,500 is at 5. That makes 3,000 at 6. And then our final is going to be 6,000 up at that top row. So if we've done this right, we'll go check it out real quick. Yeah, things look good. So you can see what the stock setup looked like before: 900, 11, 1,300, 1,500, 2, 25, 3, 4. We have that exact same thing: 9, 11, 13, 15, 2, 25, 3, 4. And then again, we gained the top ones. Now, when you make that change to that scale, the first thing I want to say is that it doesn't move around any of the actual numbers in this table and shift things accordingly. All these numbers are basically, if you just think about things in terms of, column 0, row 0, that number is the same as this one. You pick anything you want, that is still the same number as this, but since things shifted, we have to move. So basically what we're going to do is we're going to still stay with kind of the stock characteristics we're working with. So I'm going to grab everything from 900 to 4,000 and copy that. Control C on my keyboard, or you can copy it from here. And then I'm going to go into this top cell right here, which is where the 900 starts, and paste that in. And basically any cell that ended up with a different value is shaded, but you can kind of not worry about that right now. Now, the next thing we have to do is decide what to do here. Now, in a stock tune, basically anytime you're getting above 4,000 RPMs, it's just holding whatever the last available value was. So essentially in a stock calibration, you would just be repeating whatever this column was for 4,000, and you just put the same values in here and here, which is basically what those values already are. So these are the same, these are the same, these are the same. You get the idea. Okay, so right now, assuming that we don't suffer at all from losing the 500 and 700, this is still all the stock timing numbers. Nothing's been messed with there. So cool. All right, we've got that done. Now, I'm going to flip back over to that setting we changed that allowed us to have those additional columns. And I want you to read the description down here. And this is something I see a lot in various tunes. And there's 2 key tables in here that are really going to mess you up if you get lazy. So this change that we just made to that RPM column scaling across the top, well, it's actually not just used for that Spark table. It's used for a whole bunch of other tables too. So what you have to do is you need to go through these tables one at a time and make do a similar analysis of what were the values before based on the stock columns, and how do I need to shift things over or add in some additional values up top into those new areas we've just gained. So I've got this copied into Notepad already. Here's a list of all these. So we're just going to grab these guys one at a time. I'm going to do Control F to open up a find. We'll type in the first one, 901. And that takes us to our Spark base table. Now, I already know we don't have to worry about that because we've already disabled this table in the tune. Now, if you've chose not to do that and you've left your calibration so that you're still leveraging that, then you would adjust this table the exact same way that we just did the Spark C-level table. You're going to shift everything over 2 columns and then make sure that whatever your last column had, you copy that for the final 2 and you'll be okay. So 901's fine. Okay, the next one is 904A. That is the table we just did, which was kind of why we did this to begin with. So that one's already good. 905A, you can already see it here. That's your Spark altitude. We've disabled that in the tune. So again, we actually don't need to do anything, but if you chose to leave the altitude table, you do the same scaling. Okay, so these 3 you kind of treat all the same, and we've covered that. So the next table is 908. So 908 is where we start to get into some things that pertain to EGR. And so we have to do a 908A and B. So you have EGR sea level, EGR altitude. Now, for me, you notice if I double click on these, it actually doesn't even open anything because these are parameters that are not available to you if you've already disabled EGR in the tune. And just to go back and show you where we did that, because we don't have emissions on this car, we went into this EGR, and there's an EGR system type, which by default was set to Sonic. We changed that to disabled, and that basically hides all kinds of stuff because the logic is now going to be ignored. So I'm going to put it back to Sonic for a minute just so those tables come back to us. And then I'll take you to these tables and we can kind of take a look at what we're doing. But essentially, you handle this table the same way. You're just going to move everything over a couple columns. So grab everything from 9 to 4, copy that starting here, and then just make sure you repeat this 4,000 value through these final 2 columns, and that would solve it. and you would do that both for this 908A and 908B. But if you've got it turned off in the tune, then you don't have to worry about that. So I'm going to go back here and turn our EGR back off, and we're all good there. Okay, so that's 908A and B. Now we're on to 1035, and we have MAF Backflow Correction. So this is a little bit hard to discuss, but I'm actually not going to get into it for this video because you can tell very quickly this won't matter. This entire table by default from the factory is set to all ones except down at these bottom columns. So really all we need to do is just make sure that we take this original 900 column, throw it here, and then set everything else across the tune to 1. That's a very simple change, and this isn't really going to make much difference in your tune anyway, so I don't want to get into the specifics. But that's actually a very easy table to deal with. So that's 1035. We're off to 1119. So this table is your transmission's torque truncation, and it's down here in your trans folder. And just to show you again, there is nothing in this strategy. Remember, we're working with an A9L setup, which is for a 5-speed car. There is no torque truncation logic in here that's doing anything. So this whole table's zeroed out anyways, so nothing we need to do with that at all. So that's 1119, 1121, and that's your Spark EGR adder. So we talked the other day in our last video about how there's things based on coolant temp, air temp, EGR, and barometric pressure. And there's some Spark adders and subtractors that are built in. So if you're doing things like overheating or you're running really cold because you just started up, you might add or pull a little bit of timing. This is a table that is making decisions based on EGR. So again, if you've disabled that in your tune like we have, this is just another one of those things you don't have to mess with. So, so that's fine there. Okay, 1315. Fuel injector timing. Now, we're going to get into this in a later video where we start to talk about when you put custom cams in the car, what do you need to do to your tune to make it happy? And really the two big things with a cam that I always look at are this table, which is your injector timing, and where you want the car to idle. Because again, you get a really lumpy cam, you just can't have a factory idle. Factory idle is really, really low, down in the low 600s. Probably won't be happy there, and you'll have a lot of swinging idle and you know, clutching, the car will die and all kinds of weird stuff. So, but anyways, I just want to talk a little bit about what this is. So the injector timing is something that we're thinking about as far as, you know, the crank is rotating in 360 degrees, and the crank actually has to roll over twice to get through all 8 cylinders. So you actually have 720 total degrees of operation. So what this is basically telling you is at various loads and RPMs, at what point in that crankshaft rotation do we want to open the injector and create that fuel? And your timing events are going to change if you have a different cam. So if you have a stock cam, you don't ever need to change these at all, other than just accommodating whatever we've shifted over for the RPM change. But as far as what the values are in these, stock cam, leave it alone. You're fine. What I could tell you as a general rule of thumb, though, is this. If you change your cam at all, it's of course going to be a bigger cam. You're never going to put a smaller than stock cam in because they were tiny from the factory anyways. And basically with any of those cams, these numbers are going to increase. Now, how much they're going to increase, this is a pretty big topic. We'll get into that in another video, but that's ultimately what this table is. So for right now, all we really need to do is same thing we've done before. Copy starting at 900, paste it in here, grab the final column, and just make sure that's repeated here and here, which it is, and we're good to go on that. So that's your injector timing. This is going to be just fine for now until we start to have a bigger discussion around cams. Okay, 1325. Now, this is actually a really important topic, and even though this isn't Spark related, and the whole reason we're getting into this situation is because we had to accommodate for high RPM spark control, but this is a really, really important table, and I am going to go ahead and deep dive this article here. So this is talking about your adaptive uprate or your adaptive learning. So adaptive learning is basically when, you know, the computer is doing closed loop fueling where, you know, it's injecting fuel, there's combustion, you know, gases or emissions go through your exhaust, your O2 sensors pick up on that, And it's basically trying to keep the balance all the time. So it goes a little rich, starts to read, senses that it's actually getting rich, it'll swing back a little bit lean, and it just goes back and forth and everything's good. Now, when your tune's off a little bit, or the weather changes a little, or whatever it might be, altitude changes, you know, even day to day or different, you refill gas, whatever it might be, you know, even if your tune was perfect and dialed in one day, it may not be quite perfect the next day. You know, your fuel might be off 2 or 3% here and there, and that's normal. So the computer uses what's called adaptive learning to understand at each of these different cells at a given load and RPM, how much off are we averaging? What are our fuel trims? So if we're running in this cell, let's say we were averaging 5% rich as we're driving, the adaptive learning should eventually pick up on that and then adjust the fueling here. So it would cut 5% fuel to try to get things to balance back out. And it's constantly learning at each of these positions as you're driving so that it's adjusting. Now, some of these tuners out there, especially a lot of the guys that just want to do a performance-only dyno tune, not for a street car, one of the first things that a lot of these guys do is they'll tell you to remove your oxygen sensors from the factory or at least disable them in the tune. They're going to force open loop tuning where none of this stuff is even being leveraged, and they're just going to expect it to do whatever they tell it to do. But because I'm a 4-season driver and I drive street cars and I want these things to be able to go where I want them to go every single day, this is actually really important. I always leave the factory O2s hooked up, and I always leave adaptive learning turned on, and I want it to be able to make those minor adjustments again every time I refill gas or the weather's a little different on the next day. I want it to go ahead and keep adjusting. So anyways, what this table is doing is saying that when you are driving your car, you know, you're up to temp and you're just cruising around and you're staying at a position that, say, you're just kind of cruising. So maybe you're at around 2,000 RPMs and you're just holding that speed real steady. So your load is probably very low and you're probably just kind of hovering right around this cell. And when you stay in this cell for a certain amount of time, which is basically what we're controlling here, is how long do you have to sort of stay in that one spot and let the computer learn that you're either running rich or lean, and then it'll go ahead and sort of learn that, store that in the keep alive memory, or these cam refs is what they'll call that. You'll see throughout the software. And that's when it'll start to self-adjust the cam refs for that given cell. So these numbers, as you increase them, things are slower. As you decrease them, it will learn faster. Now, you also notice that some of these start with a negative number. So basically, ignore all the negatives for now. You have a few cells down here that are set really high at 100. Everything else is set to 10. So basically, the computer's telling it that in these two particular areas, don't learn quite as fast. And the reason they do that is, you know, as your RPMs are coming down, you know, you clutch in and the RPMs are dropping. This is kind of a transient area anyways. You know, the RPMs are dropping and you're moving this way across this table. And usually when you first get out of the gas, things are running a little bit rich, and then it kind of starts to lean out and adjust. Or when you first get back in the pedal, you know, you might have some enrichment fueling. And so, you know, things just aren't real steady down here. And then, of course, you also have the problem of idle potentially moving around and things swinging a little bit there. So the factory tries to make this stuff way slower right here in these cells, which originally, remember, these were 500 and 700 RPMs, but it wants things to run really slowly there as far as the learning, and then be a little faster through the rest. Now, when you have a negative number, so like look at this bottom row right here, these are all negatives. So what this means is this is not actually a cell where anything is learning. Like your car is not actually, when you're at 5 load and 900 RPMs, it's not learning anything right here. What it's actually doing is going to a specific other cell that we have somewhere in here, and whatever value it's learned from that cell that this is referencing, it's going to apply those same fueling changes here. And so the way this works, and the software's actually got a pretty good diagram here. So the way they describe it first, just read right here. When it says like -5.7, what you're referring to is row 5 and column 7. So rows go across this way, columns are this way. And these actually start at zeros on both sides. So if you look at their little simulation down here, this bottom left, this is actually 0, 0. That would be 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Then as you go up this way, you get into, 1, 0, 2, 0, 3, 0, 4, 0. And this kind of gives you an indication of what cell that is. So the first thing we're going to do is I'm going to do the same thing with what we've been doing this whole time. I'm going to take all of these values, plug all that stuff in here, make sure we copy that 4,000 to our final 2. And now we have to adjust this. So looking at the first one here, we have negative 8.2. So again, what we're really saying is that would be at the intersection of row 8 and column 2. And that's actually a special area that you can't see on this chart. That would be up here. And we've essentially taken the things from our third column and moved that all the way over to 1. So the first thing we would need to do is we'd actually want to set this to 80. We're essentially taking these second numbers and then shifting them over. So anything that's set to negative 82, I'm going to set to negative 80. And then negative 43. So again, we'd be at 0, 1, 2, 3, 4, and then 0, 1, 2, 3. So that would be the what originally starting here again 0. So going up to row 4, 1, 2, 3, 4, and then 1, 2, 3. So it pulled in what was at the intersection of 40 load and 1100 RPMs. Well, 40 load and 1100 RPMs is now here. So again, we're going to take that second number and subtract 2 from it because we've essentially shifted this stuff over to. So that's now negative 41. Same thing here. That's now negative 51, now negative 61. And then all these 57s are now going to be negative 55s. Okay. And that's, you know, without making any other changes, that's what you're doing here. And so again, if you leave, this will really mess things up. If you leave this table alone after you've changed your scaling, and it would be even more substantial when we go in later and we scale the load for these tables. This is going to do some really wacky stuff. Your fueling is going to be all messed up. You have to do this, and you have to really understand what that table is. So hopefully I described this well. Shoot me a message if you have any difficulties, but this is one you definitely want to not get lazy on. So anyways, that's what your adaptive learning is doing there. So that was 1325. That was really the tough one. And then these last two, 1328. This is one that we don't have to worry about unless we want to do something more crafty, because again, this entire table by default was set to 2s. So we don't have to change anything here to mimic what the factory computer did. And lastly, we have 1358. And this is one more I want to talk about. And I was going to make a whole other video on this one too, but I'll go ahead and just cover it now. So, you know, a lot of guys will tell you that their car's running messed up. In fact, I'm talking to a guy right now that he's having a lot of issues with this combo. And he just found out he had a really dirty air filter, so he replaced that. And it's still choking out and acting almost like it doesn't have any timing, and it's coughing and won't stay running, and it's pretty terrible. And so somebody online said, hey, why don't you just see what happens if you unplug your mass air sensor, see how it behaves. And he said, well, actually I did that, and it won't die now, and I can rev it, and it, you know, doesn't seem too angry. So what happens is when your mass airflow sensor is failing, like the wires are bad, there's something's cut, the sensor died, whatever it might be, what the computer's supposed to do is check to see if your throttle position sensor is still working. And it's probably unlikely that all of your sensors fail at the same time for some massive issue. So it's probably likely that your throttle position is still running, even though your mass air is not. So what this table is doing is saying when we can't read the mass air, well, we still have to adjust fueling, and we normally do that by reading and understanding how much air we have. So what it does instead is it says, well, let's read the throttle position sensor, which is a 0 to 5 volt sensor. And depending on where your voltage is and what RPMs you are, we create a number right here that we can tune. And this number, if you read this, it's basically saying this is a number of pounds per minute divided by the pip and then multiplied by 1,000. Don't need to get into all that math right now, but basically what it comes down to is this is measuring how much airflow and ultimately fuel we're trying to sort of infer we should have with the best guess of this. Now, there's actually a way to log this stuff, and that I probably will do in another video, where you can figure out based on your combo at a given voltage and RPM what would be a good place to put this. But, you know, chances are, I mean, this is only when the mass air sensor is dying anyways, and most of you guys have new parts and you're taking a lot of pride in what you do. So, you know, this, if it's really going to run wrong, there's probably going to be something else going on anyways, and you know, you'll be investigating it. But regardless, what we need to do right now is exactly the same. You're going to get tired of hearing me say it, but copy from 900 over, drop that in here, copy the last column, and just make sure we replicate that. That's probably good enough for now. What you may consider doing is raising these up, because technically as your RPMs go up, you're probably consuming a little bit of extra fuel. But, you know, this is probably fine for right now. If something's not running right, I doubt you're just beating the crap out of the car up in these RPMs anyways. So that's probably all you got to do. So again, to kind of recap on this video, we first started with looking at our spark table, which is right now just spark sea level. We made a decision as to which columns we don't care about. We got those out of our way. We rescaled the table. We've opened up a little bit more control up here. And then we basically just had to, you know, read that help topic and just go through every one of these one at a time and ultimately shift things over. And the adaptive learning was the tough one. So if you guys get stuck on the adaptive uprate table, let me know and I can help you out. But you definitely need to make sure that's dialed in. That's the one that'll give you the most fits. You know, it's not good. So that's that. In the next video, what we're going to do is we're going to talk about how to scale the other half of this table. And when we do that, we have the same type of thing, changing the load rows for this table to give us that high boosted area that we're going to need to dial in our tuning with. Well, yeah, there's a bunch of other tables that's going to mess with too. So again, we'll have to step through all those one at a time and adjust accordingly. So we'll hit that in the next video and try to get that posted up here in the next couple of days. I appreciate it, guys.